Welcome to Ask and Learn.
Let's start by drawing a free body diagram for this situation. And we're gonna model the all 30 skiers as one body, okay? So this is the one body, this is all 30 skiers, and they have a gravitational force of mg, and the hill here is inclined at an angle theta, which is 23 degrees. Then you have normal force, F sub n. You have pulling force, F sub p. And you have force of friction, F sub fr. And using a vector arrow to denote that they're all vectors. Anyway, this is the free body diagram in this situation. So what we do is we resolve forces first. And so in the y direction, you have normal force and force due to gravity. So normal force minus force due to gravity, which is mg sine theta, or whoops, it would be mg cosine theta, is equal to 0, right? So there's no net acceleration in the y direction. So normal force is equal to mg cosine theta. In the x direction, you have three forces. You have F sub p is acting in the positive x direction minus F sub fr, so force of friction, minus the x component of gravity, which is mg sine theta, is equal to 0. So F sub p is mg sine theta plus force of friction. Force of friction. Remember that force of friction is equal to mu sub k, coefficient of kinetic friction, times the normal force. And we just established what that is. So this is mu sub k times mg cosine theta, okay? Therefore, we have that the pulling force mg sine theta plus mu sub k times mg cosine theta. And so this gives us, if we take mg common, we get mg times sine theta plus mu sub k times cosine theta. Okay, that's the setup. That's our force. And that is really the most important part of this problem. The problem is finding the force. So force is equal to, from here, mg. So mg would be, well, each skier has 75 kilograms of weight, 75 mass, 75 kilograms times 9.8 meters per second squared. Multiply that by 30 because you have 30 skiers. And then multiply to that sine theta plus, so sine 23, theta is 23, plus mu sub k, which is 0.1, times cosine 23. Okay, and this gives us 10,645 newtons approximately for the force, the pulling force that is exerted. Right, so power now is equal to work done, average power is work done per unit time. And so work done is force applied in along a given distance over a unit time. And then that is divided over time. And so force is 10,465 newtons. Distance, it's moved 220 meters along the hill. And you divide that by 2 minutes, which is 120 seconds, giving you an average power of 19,516 watts. And now we want this in horsepower. And so we recall that 1 horsepower is equal to 746 watts. So multiply that by 1 over 746, and you get 26 horsepowers for the average power. And that's it.